Hello everyone. In this video, we are going to discuss about the proof of trigonometric identities, which comes under this topic trigonometric functions of sum and difference of two angles from the chapter 3 trigonometric functions class 11 max. See, we have already discussed about the first two trigonometric identities. The first one is sine of minus x is equal to minus sine x, and the second one is cos of minus x is equal to cos x. In this video, we will be discussing the proof of the third trigonometric identity, that is cos of x plus y is equal to cos x cos y minus sin x sin y. We will be discussing the proof of this trigonometric identity in this video, and all other trigonometric identities will be discussed. The proof of all other trigonometric identities will be discussed in the next videos, which will be available in the playlist. So here you see, we are considering a unit circle. Unit circle means its radius is 1 unit. Then the center of this unit circle is O. Then we have considered 4 points P1, P2, P3 and P4 on this unit circle. See, the coordinates of x and y coordinates of the point P4 will be 1, 0. Because you see P4, it is a point on the x-axis. So the y coordinate is 0. And x coordinate means from the origin to this particular point P4, the distance will be 1. Why? Because it is a unit circle. That is, from the center to this point P4 will be the radius of the circle, which is equal to 1 unit. So its x coordinate will be 1, y coordinate will be 0. Okay, now you see, let us consider x be the angle between, that is, I am taking this angle P4 O P1 as x. That is, let x be the angle P4 O P1. That means P4 O P1, this angle P4 O P1, this angle is x. Let x be this angle P4 O P1. Similarly, let y be the angle P1 O P2. That is, angle P1 O P2 is taken as y. P1 O P2. That is, this angle, this is taken as y. Okay. Then, what will be the angle P4 O P2? That is, from here to here, what will be this total angle P4 O P2? That is this angle. See, angle P4 O P2 will be equal to what? Angle x plus angle y. So, angle P4 O P2 will be equal to x plus y. Okay, now let minus y be the angle P4 O P3. That is, angle P4 O P3, that is taken as minus y. Okay, so angle P4 O P3. So I am just measuring this angle in the clockwise direction. That is why the angle is minus. So I am taking this much angle as minus y. So you see, this angle and this angle y, both will be having the same value. But there is a negative sign here. Why? Because it is measured in the clockwise direction. So angle P4 O P3, that is equal to minus y. Now you see, I have just joined these 2 points P1 and P3 using this straight line. And I have just named this point which this line intersects on this axis as M. Okay, now I am going to consider the triangle OMP1. That is, triangle OMP1. I am going to consider this triangle OMP1. You see, this is a right angled triangle. So I am considering triangle OMP1. So in this triangle, you see, from here to here the angle is x. See, from here to here this total angle will be 180. From here to here it is x. So what will be this angle? This angle will be 180 minus x. That is angle P1OM. Okay, angle P1OM, that will be equal to 180 minus x, because from here to here the total angle will be 180. From here to here we have x. So this angle will be 180 minus x. So angle PMOM, that is this angle, that is 180 minus x. Okay, now here if you find out cos of 180 minus x, see, cos x is equal to adjacent side by hypotenuse. So adjacent side is OM or MO. divided by hypotenuse. Hypotenuse is OP1. Okay, see this can be written as OM divided by this OP1. This is actually the radius of the circle, no? From the center to any point on the circle, that will be equal to the radius. So OP1, that is actually the radius of the circle. Okay, now you see cos of 180 minus x. Cos of 180 minus x is actually equal to cos of minus x. Okay, cos of 180 minus x is equal to cos of minus x. This is equal to OM divided by R. That is, you see, cos of minus x is actually what? That is an identity. Cos of minus x is actually equal to cos x. So, cos x is equal to OM divided by R. That is, from this we can write this OM is equal to R into cos x. Okay, OM is equal to, in general, we can write it as OM is equal to R into cos x. See, what is this OM? It is actually OM, that will be actually the x coordinate of this point P1 now. Okay, see, this distance OM, when you consider this point P1, it will have one x coordinate and one y coordinate. X coordinate is actually equal to OM and y coordinate will be equal to MP1 or P1M. Okay, so you see OM, that is the x coordinate of this point P1. Okay, so here we can say that it is the OM which is equal to R cos x. That is, we can say that the x coordinate of this point P1, it is actually the radius times the cos of, R is radius, the cos of radius times the cosine of the angle made by this point P1 with the positive x-axis, because you see OM is equal to R into cos x. Okay, OM, that is the x coordinate of this point P1, which is equal to radius times cos x. Cos x means it is the cosine of this angle x. This angle x is actually measured from the positive direction of x-axis to this point P1, no? So, x coordinate of the point is actually the radius times the cosine of the angle made by this point with the positive x-axis. Okay. That is, here we can write the x coordinate OM is equal to radius. It is a unit circle. So, radius is 1 into cos x, cos x. So, you see, when you consider this point P1, x coordinate will be cos x. Okay, now what about its y coordinate? Now you see, to get the y coordinate of this point P1, we actually want to get this distance MP1. That will be equal to a distance corresponding to this length as well. That is, when you join this P1 here from O to this point, that will be the y coordinate, which will be equal to this MP1 distance. So, to get the y coordinate of this P1, what I am doing is, I am going to find out sine of this angle. This angle is actually what? 180 minus x. Okay, this angle P1 OM, this angle is actually 180 minus x. So, here I am going to find out sine of 180 minus x. So, sine of 180 minus x will be equal to what? Opposite side by hypotenuse. Opposite side is MP1, which is the y coordinate. Hypotenuse is OP1. Okay, that OP1 is actually the radius, which is equal to 1 unit. So, here you see sine of 180 minus x is equal to opposite side MP1 divided by hypotenuse, which is OP1. This is equal to MP1 divided by OP1 is actually the radius. So, R, we are writing it as R. Okay, so sine of 180 minus x. Sine of 180 minus x, that is actually equal to sine x. So, we can write sine x is equal to MP1 divided by R. Okay, from this we can write MP1, this is actually equal to R into sine x. That is, the y coordinate of this point is radius times MP1, that is the y coordinate. So, y coordinate of this point is radius times the sine of angle x. That is radius times the sine of angle made by this point with the positive direction of x-axis. Okay, so y coordinate is the radius times the sine of angle made by this point with the positive direction of x-axis. So, we can write in general MP1 is equal to R sine x. Okay, see, in our case it is a unit circle. So, radius is equal to 1. So, we can write MP1 is equal to R is 1, so sin x. So you see this is the y coordinate of this point. So we can write the y coordinate of this point as sin x. So the x coordinate and y coordinate of this point are cos x, comma sin x. Similarly, when you consider this point P2, this also will have one x coordinate as well as one y coordinate. See, the x coordinate of this point P2 will be the radius times the cos of angle made by this P2 with the positive direction of x-axis. Okay, so you see x coordinate of P2, x coordinate of P2, that will be actually the radius times the cos of angle made by this P2 with the positive direction of x-axis, that is this much angle. This much angle is actually equal to what? X plus y. So cos of x plus y. Okay, so x coordinate of P2 will be equal to r times cos of x plus y. See, r is a radius which is equal to 1 here. So x coordinate of this point P2 will be r is 1, 1 into cos of x plus y is cos of x plus y. Okay, so you see the x coordinate of this point P2 is cos of x plus y. Okay, now what about the y coordinate of this point P2? See, the y coordinate of this point, y coordinate of a point is actually radius times the sine of angle made by that point with the positive direction of x-axis. So y coordinate of this point P2 will be equal to radius times sine of angle made by P2 with the positive direction of x-axis. Okay, that is x plus y. Okay, here radius r is equal to 1. So the y coordinate of this point will be 1 into sine of x plus y, that is sine of x plus y. So its y coordinate is sine of x plus y. Okay. Similarly, when you consider this point P3, this also will have one x coordinate as well as one y coordinate. So you see x coordinate of, I am considering the point P3, x coordinate will be equal to radius times the cos of angle made by this point P3 with the positive direction of x-axis. That is, you see the angle made by P3 with the positive direction of x-axis is actually minus y. So cos of minus y. Okay, see radius is actually equal to 1. Cos of minus y is what? Cos y, or you can take it as cos of minus y. So you see the x coordinate of this point P3 is cos of minus y. Okay, now what about the y coordinate? Y coordinate of the point will be radius times sine of angle made by this point with the positive direction of x-axis. So you see this is the positive direction of x-axis. This is the point P3, the angle between them, that is actually minus y. So sine of minus y, radius r is equal to 1. So this will be sine of minus y. So you see the y coordinate of this point P3 is sine of minus y. Now when you consider the fourth point P4, you see this point P4, it is on the x-axis, so its y coordinate is 0. X coordinate will be the distance from the origin to this point, which is actually equal to the radius of the circle. Radius is 1 unit. So 1, 0 is the x and y coordinates of, that is the position coordinates of this point P4. Now here you see, I have just joined these two points P2 and P4 so that we are getting a triangle here which is P2 or P4. Okay, we are getting a triangle here. I have just joined them with a dotted line. You can just join them with a solid line, no problem. I have just joined them with a dotted line from P2 to P4 so that we are getting a triangle here, P2 or P4. Now what I am doing is, I am going to consider the two triangles. That is, one is triangle P1 or P3. Okay, I am considering this triangle P1 or P3. That is this triangle. Okay, then I am going to consider this triangle as well, which is P2 or P4. Okay, I am considering this triangle P2 or P4. Okay, you see these two triangles are congruent triangles. These two triangles are congruent triangles. Okay, why? Why? Because when you consider this triangle P1 or P3 and triangle P2 or P4, you see Here when you consider triangle P1OP3, see this side OP1, okay, which is a radius of the circle, that is actually equal to this side OP2 of the second triangle now, because OP2, that is the side of the second triangle P2 or P4, and this is actually equal to the radius, so OP1 will be equal to OP2. These two sides are equal. Similarly, when you consider this side, which is OP3 of the first triangle, OP3, which is also the radius, and when you consider this side OP4 of the second triangle, both are the radius, so both are equal. Okay, and when you consider this angle of the first triangle, see this angle, the total angle, that is when you consider this triangle P1 or P3, I'm talking about this total angle, okay, this total angle, that is actually equal to the angle y plus some value is here, angle y plus some value. Okay, similarly when you consider the second triangle P2 or P4, what about this angle? This angle is also like, this is minus y, minus is because it is measured in the clockwise direction, that's why. Anyway, this angle is y. So when you consider this angle of the second triangle, this total angle of the second triangle, that is actually equal to y, angle y plus some angle. That some angle is actually the same for both, no? That means this total angle will be equal to this total angle of the second triangle. Okay, so here you see the two sides and the included angle, that is this angle. Okay, here when you consider these two triangles, the two sides and the included angle are equal. So we can say that these two triangles are congruent triangles. Two sides and the angle. Okay. You see, when you consider these two triangles, triangle P1 or P3 and triangle P2 or P4, the two sides of the two triangles are equal and the included angle is also equal. Angles are congruent. So these two triangles are actually congruent triangles. So then the third side of these two triangles must be also equal. So you see, what about the third side of the, see we have talked about this side OP1 and OP2. So what about the third side, OP3, OP1 and OP3 of the first triangle. So the third side of the first triangle is P1, P3. So P1, P3 will be equal to, since these two triangles are congruent triangles, the third side also must be equal. Must also be equal. So you see third side P1, P3 of the first triangle will be equal to the third side P2, P4 of the second triangle. Now you see, when we consider 2 points A and B with coordinates x1, y1 and B with coordinates x2, y2, then the distance between these 2 points will be equal to square root of x2 minus x1 all square plus y2 minus y1 all square. This is the formula. Okay, so square of the distance between these 2 points will be equal to this, we don't want to consider this root now. So this will be like x2 minus x1 all square plus y2 minus y1 all square. So this formula is actually known as distance formula. Okay, this formula is actually known as distance formula. So here you see we have the distance formula as like this. So here by using this distance formula, we can write the distance between P1 and P3, or the length P1, P3 will be what? Distance square. So P1, P3 is the distance between P1 and P3. So P1, P3 all square, that will be equal to x2 minus x1. That is the x coordinate of the second point minus x coordinate of the first point. So P1, P3, no, x coordinate of the second point is cos of minus y. So this will be equal to cos of minus y minus x1, which is the x coordinate of the first point, which is cos x. So cos x whole square, okay, plus y2 minus y1. See, y2 is the y coordinate of the second point, which is sine of minus y. So sine of minus y minus y1, which is the y coordinate of the first point, P1 which is sin x. So sin x. Okay, so you see this can also be written as P1 P3 square is equal to cos of minus y is actually cos y. Okay, minus cos x whole square plus sin of minus y is actually what? Minus sin y minus sin x. Okay, so this can be written as cos y minus cos x all square. Then you see I'm going to take this negative sign outside of the second term. Sorry, here we have square, no. Okay, second term square is also there. So I'm going to take this minus sign outside, but it will be there in the bracket itself. That is, this can be written as minus of sin y plus sin x whole square. Okay, minus of sin y plus sin x all square. So minus square will be plus. Then rest we have sin y plus sin x all square. Okay, now I'm going to expand these cos y minus cos x all square. So this is like a minus b all square. A minus b all square. So this is like a and this is like b. A minus b all square is actually what? A square. So cos square y minus 2ab. So minus 2 cos y cos x. Okay, plus b square, that is cos square x, plus a plus b all square. A plus b all square, that is a square, so sin square y, plus 2ab, that is 2 sin y sin x, plus b square is sin square x. Okay. Now you see this will become P1 P3 square is equal to cos square x plus sin square x is equal to 1. Cos square y plus sin square y is equal to 1. So 1 plus 1 will be 2. Okay. Then this is like minus 2 cos y cos x. Then plus 2 sin y sin x. So I am taking minus 2 common. So the first term will become cos y cos x. So you can write cos x cos y minus, because we are taking minus outside, no, it is plus here. So there will be minus here in the bracket. Sin x sin y sin x, or sin y sin x. Okay. And I am going to consider this equation because this equation is important for us, because by comparing another equation we are going to derive our identity. Now here you see P1 P3 will be equal to P2 P4 now. So P2 P4, I am going to find out this distance P2 P4. So as per the distance formula, the P2 P4 square will be equal to what? X2 minus x1 all square. So x coordinate of P4 is 1. So 1 minus x coordinate of P2 is cos of x plus y. So cos of x plus y whole square. Okay, x2 minus x1 all square plus y2 minus y1 all square. So y2 is the y coordinate of P4, which is 0. Okay, minus y coordinate of P2 is sin of x plus y all square. Okay, so here we can write it as P2 P4 all square is equal to, okay, see, I am going to just expand it, a minus b all square. So a square, 1 square is 1, minus 2ab, 2 into 1, 2 into cos of x plus y, plus b square, b means cos of x plus y. So b square cos square of x plus y. Okay, plus 0 minus sin of x plus y will be minus sin of x plus y all square. So minus square plus, then sin of x plus y all square is sin square of x plus y. Okay, so we can write P2 P4 square is equal to cos square of x plus y plus sin square of x plus y will be equal to 1. 1 plus 1 is 2. So 2 minus 2 of x plus y, cos of x plus y. Okay, so I'm going to consider this equation as well. So here you see, we already got P1, P3 square as this and here P2, P4 square as this. See, since the two triangles are congruent, we said that the third side must also be equal. That is P1, P3 will be equal to P2, P4. Since P1, P3 is equal to P2, P4, square of P1, P3 will be equal to square of P2, P4. So P1, P3 square will be equal to P2, P4 square. That is, these two equations will be equal. Okay, so P2, P4 square will be equal to P1, P3 square. So left hand side of both the equations are same. So we can equate their right hand sides. So when we equate their right hand sides, we can write 2 minus 2 into cos of x plus y is equal to 2 minus 2 into cos x cos y, okay, minus sin x sin y. Okay, so you see, when you take this 2 to the other side, it becomes minus 2. So this plus 2 and this minus 2 on the other side will become, they become cancelled. Then rest we will be having minus 2 cos of x plus y is equal to minus 2 and this term. So minus 2 and minus 2 can be cancelled because when you take minus 2 to the other side goes to the denominator like that. So rest we will be having cos of x plus y. See, I haven't just cut like this. Okay, when you take this 2 to the this side becomes minus 2. So that minus 2 and this 2 will become cancelled. Then rest you will have, you don't have this 2 now. Then you will have minus 2 of this term is equal to minus 2 of this term. So when you take this minus 2 to the other side goes to the denominator, that minus 2 and this minus 2 cancelled. Rest you have cos of x plus y is equal to cos x cos y minus sin x sin y. So this is the third trigonometric identity. Okay, so the first trigonometric identity is sin of minus x is equal to minus sin x, and the second one is cos of minus x is equal to cos x, and the third trigonometric identity is cos of x plus y is equal to cos x cos y minus sin x sin y. See, we will be discussing all other trigonometric identities in our videos which will be available in the playlist. So I hope this derivation is clear to you, this proof is clear to you. Thank you.